Lens rigid body motions. Like all other optical or optomechanical elements, in order to constrain an individual element, we need to constrain 6 degrees of freedom, which includes 3 translational constraints, which we call it Tx, which is translation around x, Ty, translation along y, Tz, translation around z, and we have 3 rotational constraint, which is Rx, rotation around x, Ry, rotation around y, and Rz, rotation around z. For a lens system, which is usually is axisymmetric along the optical axis, we have a name for each degrees of freedom that needs to be constrained. Or when we want to see the effect of tolerancing on each parameters, we have usually, for example, we say what is the effect of decentering a lens element. Now I'm going to talk about the name convention that we use for individual lens element that in future will help us to understand the requirement for an optical system, in a better form. So as I said, for an axis-symmetric optical system, for an individual lens element, we usually select z-axis along the optical axis of the system. So for this lens, it's fully symmetric. The optical axis is this axis, so we use z in this axis. And most of the time, when we want to see the effect of the movement, we look at YZ plane. Especially in Zmax, we usually look at YZ plane. So the first parameter that we talk about it is decenter. What does it mean when we say we decenter a lens element by 100 micron? Decenter means translation in x or y, and we usually or delta x or delta y, and we usually use translation in y because the system is fully symmetric, and we select y as our main translation, which doesn't matter. You can select tx, but we usually use ty. And the other parameter is d-space. What does it mean when we say this lens is d-spaced by 100 micron? D-space means translation in z direction or along optical axis. We have a parameter which we call it tz, which is translation in z direction. What does it mean when we say this lens is tilted by 0.1 degrees? It means that the lens is tilted around Rx or Ry or x-axis or y-axis by 0.1 degrees. This rotation is about the axis perpendicular to the optical axis. So we usually, because as I said, YZ plane is important for us, we usually, when you want to see that effect, we rotate the lens around x-axis. Another parameter that is not very important. So right now we talked about 5 degrees of freedom: Tx, Ty, Tz, Rx, Ry. As you might guess, the next element is Rz. Rz, we call it clocking, which is the rotation about the optical axis. This parameter is not that important for us because, as I said, lens is an axisymmetric optical element. So we have one parameter for that, which is Rz, but for some other systems that we have astigmatism, or we have any kind of birefringence or polarization dependence, that there is a not symmetrical elements, rotational symmetric elements around z-axis, this parameter can play an important role. So when we want to define a lens element geometrically in a space, we need to have 4 basic geometric parameters. We can have many more parameters like the wedge of the lens, wavefront error, coatings, a lot of things. But for a very, very simple optical lens element, we only need to have 4 basic geometric parameters, which is radii of curvature R1, radii of curvature R2, or CT, which we call a center thickness from here to there, and the diameter of the lens. So by defining these 4 parameters, we can define a basic geometrical lens element. Thank you very much.